Yes, and so can our audience now.
So my newest fidget toy.
Ooh, did you print it?
I did print it, and my wife immediately stole it from me. So I'm borrowing it back, even though it was mine originally.
What is it?
There's this trend. 3D printing community has like trends of these. They call them impossible X, impossible vortex, impossible tower, where the shape doesn't look like it would fit together, and then it like very satisfyingly fits together.
Oh, nice.
And this one I found, which is kind of cool. So you see the vortex here, and you see the vortex here. The pattern is very, pretty neat. And so, like, you look at it from a few angles, you're like, how does this fit into that? Like, you probably can't, it's getting washed out. But needless to say, there's one exact spot where it slides in, and then it kind of slides out. The original one,
both sides. That's cool.
Yeah, it looks like it's like kind of moving in weird directions. Yeah, this was fun.
Where do you find your designs?
For anything like this, anything intricate, honestly, Printables, which is created and maintained by Prusa, but they have designs from anyone. And more recently, Maker World, because I have a new bamboo printer and they have their own like mini thing. Honestly, people just post on the third site too, which I don't go to that much more, which is Thingiverse. The same file. Like if you're sharing something that's free and open source, you want to get as much people to look at it, so they just kind of upload it 3 times. They're all kind of the same. And then I designed some stuff myself, but like nothing complex like this.
Yeah, cool. All right. Well, I know Chris is going to join us in a bit, but we can probably start off with just doing our pipelines recap for the week.
What have we been doing with pipelines?
What have we been doing? Have we been doing anything? I think we have. Yeah. We can let's look at our blog and see. We usually post stuff over there. All right. So, screen share. Well, we have a few bits of news this week. Not all of them pipelines related. You know what? Let me open this so I don't have to see my little admin tab up there.
I think the last pipeline release we had for the previous week, which we did cover, was the struct to JSON one, which was pretty neat.
I think you're right. So let's struct to JSON. Talked about that last time. And so this week we've got 2, one on Tuesday and one on Thursday. So the first one was our new pipelines data destination for Kafka. So I'm sure a lot of folks are familiar with Kafka. It's kind of the premier, I would say, open source stream processing platform. And obviously it is open source. It's under the Apache Foundation. And there's lots of folks who run the open source distribution. There's also a lot of proprietary distributions of it, as well as cloud hosted platforms. So somewhat different than the AWS S3 example, which I know someone asked a question about the week we announced that, if it was generally compatible with all S3. In this case, the Kafka destination is compatible with anything that's Kafka API compliant. And so some examples of that are Confluent, obviously, which is from the creators of Kafka. Red Panda is a Kafka compliant stream processing platform that is kind of a rewrite and go. And there's a lot of other examples as well. Actually, interestingly, Azure Event Hubs, which we have a existing destination for, is also Kafka API compliant. So you could target it via our existing destination or the new one. But yeah, this is just a new data destination that allows you to send data to a Kafka topic. And yeah, so it's available now. You can check out the documentation and let us know how you're using it.
Yeah, and I think there's some differences between Kafka and S3, independent of Goliath and IoT. That's like a very strong protocol, and people adopt this protocol even if they're not using the Kafka code. Yes, destinations everywhere, everything's everywhere. And we even see it in places that are not like the more bespoke. So you mentioned proprietary implementations of Kafka, the stack, but like using it in ways that are not mapping to sort of the Kafka technology, I think is a good sign of a well-designed protocol, or just a protocol that meets needs. Like Azure Event Hubs, it's nothing. They're not using Kafka anywhere as far as we know, but it's part of their Event Hub system. It just means compatibility. So we've heard a lot of people ask for it, so it made sense, and good to get that out.
Yeah, absolutely. It's also another destination that supports any content type, so you can send binary data through Kafka if you like. That's also true for things like PubSub and Azure Event Hubs and things of that nature. However, the formatting is a little bit different there, which is kind of a result of a legacy attribute of the Goliath platform about how those used to work, where we would take the full event, put it into a JSON object, and base64 encode the data within that as a field. We'll likely in the future release new versions of those destinations that use the metadata more natively, if you will. So, for example, a Kafka event has a payload, but also has metadata associated with it. And if we actually jump over into the documentation, I can show exactly what this looks like. So, in the documentation, you can see in this case, we're sending JSON, but the payload is it matches in the input and output. And then we use event metadata headers, which is just links over to the Kafka documentation. But basically, there's a metadata concept in Kafka events, and we leverage those to put things like the event ID and the project ID and the device ID. So using the protocol natively. And if you compare that to something like GCP PubSub, we're actually taking all of that metadata and putting it in the payload. And like I said, there's a variety of reasons for it. Some of it is support of the different destinations. Some of it's that legacy capability that I mentioned before. But that's one thing to note about these two that are a little different.
Cool.
All right. So we had one other pipelines announcement this week, and that's our base64 transformer. This supports both encoding and decoding to and from base64 data. This is especially useful if you are unable to support binary data in a given destination, or you want something to be, text-based for any reason at all, or you're sending base64 data and need to decode it before it goes to its final destination. So this is really kind of a utility. We mentioned a couple of examples in this blog post. Once again, you can look at the documentation for more. I will say that next week we're going to have some more transformers coming out that are going to make this especially useful. So we intentionally kind of held back in this blog post, but keep an eye on the blog next week, and we'll show you some interesting stuff.
Yeah, and I was surprised as we're working through use cases and you were drafting this blog post, just how often we see base64 kind of sprinkled in. And I think it's common enough from interfacing with, say, literally the web, so like a web app that needs to talk to some sort of backend with just a little bit of binary data. Maybe it's not an image, maybe it's not an audio file, but like it needs to be transported. And yeah, it's not that easy to deal with that. So having this in the pipeline just means you can easily connect to those existing APIs, and a lot of consuming APIs that we were looking at just requires basic for encoding for any binary data. So easy transformer there.
Absolutely. And I think you mentioned a good thing there, that this is kind of alluding to what we'll put out there next week. But when you're mixing text-based data and binary data, this especially becomes really useful. If you think of some of your text-based formats, that'll give you a hint about some of the transformers we'll have next week. But yeah, that was the big pipelines announcements. We also had another big announcement, and it looks like Chris is here just in time to talk about it.
Not talking about hardware yet?
Right. You were intentionally delaying for the hardware.
I didn't want to.
What an entrance!
I didn't want to jump in the middle of base64 and then be like, Chris, any thoughts about base64? And be like, I do not have any thoughts.
No thoughts here. Nothing going on over here. But okay, so we open source Goliath hardware. Do you want to talk a little bit about what the hardware is and what open sourcing it entails?
Sure. So we've been we do a lot of open source here at Goliath, including our SDK, our firmware designs, just a lot of the stuff that we do, some of the stuff that Dan's pushing back to CoApp. So it's part of our DNA, if you like, and the hardware that we've been building for a long time for internal demos has not been available. It's still not available for sale, but it is now available for people to build themselves if they want to. And so the two things that you see on the screen right there, that's on the left side, that's the Aludel Elixir, and the right side is the Aludel Ostentis. Those two basically go into a off-the-shelf case you can buy, and the black PCB is like a front panel that you can use. It's got e-ink and touch and stuff like that. And the Elixir, the whiteboard, is that is NRF 9160 running NRF Connect SDK with the Goliath SDK on top of that. Then there's also an ESP32C3 offload Wi-Fi on there. Just a bunch of sensors and things like that. On the backside, there's the microbus click headers as well, so that it's like really flexible. And that's really the key there. And we use that for all of our reference designs to build kind of vertical demos for different industries. And now people can, before they could buy off-the-shelf hardware like development kits and plug-in boards and stuff like that. Now the other stuff that we show, though, the kind of the enclosed case, people can do that themselves if they want to as well. And we'll have some more announcements about that in the coming weeks as well. So yeah, open sourcing is really kind of cleaning up my schematic and layout and making that look better, and checking. Like the way you really know hardware is working is to build it and try it, and we've been doing that over the past couple of months. And so yeah, this is the hardware that we use in our reference designs, and it's out there now.
Awesome. And one thing I like to think about as we're talking about open sourcing is this was kind of the plan all along, and you really got to pass the finish line. Mm-hmm. When we talked about open sourcing our reference designs and our reference design templates, we thought it was a good example of how to build applications using Zephyr and dealing with IoT and obviously using Goliath. But we got a lot of feedback that's actually helped a lot of people. And this is not intended to show you how to build a mass production device, but it certainly is a good example of how to interface and design in, cellular plus Wi-Fi plus some sensors, and represent a lot of the applications we're seeing being designed in, and whether it's using the exact template and the reference design itself, or just to be a good tool to study. I think it's great to have that in the ecosystem.
And so one of the values of the kind of the end-to-end reference designs as well is being able to kind of peek in and see how, outside of like the individual samples that you might see on Zephyr or in our SDK or NCS and things like it, it's like those are usually very focused for testing capabilities, but this is kind of gluing a lot of that stuff together and gluing all the Goliath capabilities together too. So you could see how we use remote procedure calls, how we use the setting servers, how we do OTA, that sort of thing. And seeing it all together is kind of an ad hoc kitchen sink demo. And at the end of the day, it's like a 80% done design that you can go and take and modify and build yourself. So,
yeah, we can't actually count how many times someone says, we're actually building something like that reference design, but slightly different. And really, it's a good example of getting someone closer to that 80%.
Yeah.
Cool. Awesome. Well, this is great to see. I was curious, there's kind of like open source hardware means a specific thing, and I know this is released under the OHLP license, as it says there. What does open hardware actually mean?
It means a lot of things to a lot of people, and there's been a lot of strife over that definition for a long time. So I'm gonna just say what I when I think of this sort of thing. And it's basically making sure your design files are readily available so someone can go and replicate it themselves. And really that's what this is. So in our case, it's a GitHub repository with KiCad 8 files in it. So it's got schematic, it's got layout, it's got BOM information. Excuse me, other times you see files, they might not have all that stuff there. And it might not have like all the purchasing information, so it's not quite as easy to go and build it yourself. That's fine, right? It's in terms of like derivative works, it really is going to depend on the creator and how they choose to release info. but we let it all rip. So it's out there.
Awesome.
And I will refer back to the blog post. Chris has a section on open hardware, open source licensing, what this is and what this maybe isn't to those people who might have different definitions. That was a good explainer.
Yeah.
Yeah, the licensing certification.
Yep.
Awesome.
There's also been, Dan showed up on the Wednesday stream, as did Mike, and we've been progressing, basically taking that Elixir board and, kind of moving it to an even smaller form factor. That's called the DRAM board, and we're continuing that work. And some of that will go towards Sloshy McWashy, as well as additional generated art.
Talk a little bit about, for folks who maybe who haven't tuned into the Wednesday stream, how what you're building there is going to be useful for Sloshy McWashy and maybe some of the components that we talked about last week on the stream.
Yeah. So if you look at the Elixir, it's in a rather large form factor, and that's for the microbus click form factor. It's really maximized for that. But those are larger boards. It's really for maximum swappability and just like being able to try out a lot of different sensor designs and that sort of thing. Most of the time when you're going towards an actual product design, like what we're talking about here, you're going to start shrinking things down. You're going to be more compact. You want to, design something that is, just kind of a more finished look, right? We think that the Aludel stuff is the Astentis and the Elixir are approximate that, or might be an industrial style thing, but you're going to start shrinking stuff down. And so really taking some of the essence of that Elixir, we should have called it that. And even to the point where I think in the future, the DRAM, which is kind of a subset of all the things that are on the Elixir, we're going to probably take the DRAM, which is like a castellated edge module, and then put that back onto future versions of the Elixir, and just to kind of dog food that sort of thing. And the reason you would want to do that sort of thing is that you maybe have the Elixir being a test platform, you want to have a lot of access to pins and being able to quickly plug stuff in and have different interfaces and stuff like that. But at the end of the day, when you're making a product like Sloshy McWashing, you want to make it like small and tight. You want to basically lift off the parts that you're really using and put just the stuff you're using onto the product. And so that's what the DRAM module will be. And in between the stuff that I've been interested in, taking the Elixir and kind of moving it to a smaller module, the 9151 from Nordic instead of the 9160. And then also our discussions last week with the BG77 and ESP32C3, I was like, well, maybe the DRAM module could actually be more of an abstraction of kind of the essence of what the Elixir is enabling. And so that when you do drop it onto a different thing, it actually, Goliath is really good at making it so that you don't need to just use one type of RTOS or one type of vendor ecosystem. If you have kind of a defined outline for this module as well, then you actually move it up a step as well. Now you say, oh, who's running the show? Is it the NRF52840, or is it the NRF9151, or is it an ESP32S3, or is it a insert new chip vendor here? It actually ultimately it's talking to the edge connection modules, and if you're talking to edge connection modules, you're okay, right? I mean, you could start to everything then becomes a firmware/software problem.
And talking about like shrinking, expanding, abstracting, specializing. From my experience working at hardware companies, that's just the name of the game. And it's actually really good to have a tool to do that. I can't share numbers. I also don't remember the exact numbers, but I remember reviewing the first generation Nest thermostat and the margins. And the third generation Nest thermostat had some changes and some improvements, but like the margins was significantly higher, company making significantly higher, because they just not only did they have supply chain and buying power, but actually just cost reduction and specialization. And so obviously they probably could have done that earlier if factors would allow that, but starting with something like a DRAM module probably could go in a finished product, and then second generation you put it down, and then maybe you have a sibling product that's still a bit cheaper even still, because you're not using all those capabilities. That's good. That's just the art of designing hardware.
Yeah. Yeah, and I think and that's a really good example too, because like as you go through different iterations, I still have scars from the the part shortages 22, 23, whatever, right? This is one way to think about it, is like that. Another way is like John's talking about with like cost down type things. But ultimately, like if you have something like a thermostat, where you have like a push button that's going to activate things, your push button is probably always going to be on the same like input to this compute section of your device. And in this case, it's going to be to the castellated pin that's on the edge there. And so this is not a new idea. This is, friends, competitors, past work. Like I've built boards like this before. It's not a new idea, but it is a tested idea. So we're gonna keep doing it. Just different parts.
Awesome. Cool. Well, last week we did some planning around what components we were going to have on the board. As far as things that we could tackle today, one is we could talk about how we go about sourcing components. I think that's an interesting conversation. And obviously there's like the aspect of that for like dev boards and things like that, so we can get started on development. And then the other side is actually putting together a PCB, right, and getting the components for that, and working with manufacturers and things like that. So we could talk about that maybe a little bit. We could also get started with putting like the structure of the firmware into the repository. Obviously, we don't have all the components, so we won't be able to actually interact with everything. But we could go ahead and start to get that set up. And then there was one other thing that I feel like I guess hardware or PCB design. We could do some of that if we want to. But where do y'all think we should start this week?
So I can tell you. So one of the reasons that the DRAM planning exercise is really useful is I started to do what seems to be part of any project, which is spreadsheet pin planning, right? And I'll pull mine up right now if I can find the window.
Spreadsheets, the original low code.
Yeah, the original and continuation of. Yeah. All right, so this might be a weird window format. It's okay. Well, let's try and do this. See if this helps. Does that help a little bit?
Yeah, I think it's fine.
Okay. And so what I started doing is this is basically just pulling out the Elixir pins and pin names and pin functions and stuff like that. And then what I really wanted to know is like, do these have to stay on module or off module? And really the only number I really care about is this one right here. So number of unique GPIOs required, because ultimately that's going to feed back into the design and the chip choice, right? So we had talked about the ESP32C3 last time. And so what I started wondering is, well, if we're going to have, so first off, some of these things I say, well, could these be on an expander? What I mean by that is a GPIO expander, something like a I2C. There's actually ones in Zephyr in ESP-IDF where you abstract them out, where you treat them like a GPIO in code, but then some of the lower level drivers talk over I2C or SPI or whatever the communication mechanism is out to the expander, and then inputs and outputs are triggered as excuse me, like say a button press comes into a GPIO expander that's set as an input. It then fires an interrupt that then tells the processor, hey, I've got a new input here. Again, the processor could also set its one of its external pins as an input and then have an interrupt fire on that if you set it up in firmware. But basically kind of abstracting that same function and saying, oh, this is happening on the GPIO expander now. The reason you do this sort of thing is because you run out of pins for certain things. Sometimes it's just a waste to have a single button that gets pushed every once in a while on a input to a microcontroller. Pins are expensive. And so I started thinking, like, could some of these things go onto an expander? And it turns out, yes, some of them could, right? So like things like this one, this is the thing that enables the 5-volt boost for the microbus click header. That gets fired like at boot, and then sometimes it's turned on and off in like low power states, but like very low and slow.
For like these expanders, they're slower, right? So like you're kind of in your classification is like not that often. Not like a UART pin typically.
Exactly. Not using like the internal. Usually, there's custom silicon internally for like handling an I2C. So like, just to use the Nordic example, right? They actually have four different kind of digital interfaces that you can assign functions to, like serial processing, and that's pushing stuff out over I2C without having to bit bang it. Bit banging being like, oh, go high, go low, go high, go low, and actually interrupting your processor to do that sort of thing. Instead, you write to the register for the I2C peripheral. You say, here's a byte. It goes, and it just sends it out without you thinking about it. And if data's coming back, it does a callback, that sort of thing. So yeah, I would not want to assign that to a I2C. That's a much more complex thing that you need to do on an expander. Not impossible, but not worth it. But something like this, the 5-volt enable, no problem, right? I mean, like basically it's like just go high once in a while. And in something like Zephyr, ESP-IDF, whatever, you can map that stuff out as well. It becomes
so it's your application just sees it as a normal GPIO?
Yes. Yeah.
Oh, that's cool.
It's really cool. Yeah. And it has to have a driver, right? That's what the driver layer does. But then when you're writing, a program, the application in Zephyr, it's like you just treat it the same as a GPIO, which is super cool.
Yeah, I think one of the things that this may be like kind of a basic point, but one of the things that I think is really interesting about like IO and maybe not really apparent to someone who doesn't work with low level software frequently is that like if you're doing like bit banging or something like that, you're very rarely reading values like off of a pen, right? You're almost always having some piece of silicon that is taking values and putting them into memory, usually via DMA or something like that. And then you're accessing that memory from, wherever your application processor, wherever that's running. And I think that's like, there's a lot of configuration of that setup that can impact what's possible, right? So I think a good example is we've been doing a lot of stuff kind of randomly with audio recording recently, and depending on how often you're sampling, what your sample depth is, that sort of thing, and how big your DMA buffer is, that's going to control how much you're actually, if you're able to record audio at a certain rate, right? And if you have a DMA buffer that's too small or you're not reading from it fast enough, it's going to get overwritten, right? So you have to be aware of all of these things with your application processor. But if you didn't have these bits of silicon, all you would be able to do is read in the audio, right? You couldn't do anything else in your firmware because you would be missing data that's coming in. So I don't know. I think that's like an important concept that folks may not realize when first kind of like getting into these things.
Yeah, that's a good point. One thing that did pop out from this analysis is that, like, yes, we could put a bunch of stuff onto an expander. So, like, one thing I talked about in the hardware streams and also I think last week is like we're kind of operating open loop. We don't have a budget. We don't have size constraint, and sometimes that's actually harder. Right? And it's usually this really like push pull, like. If you're working with a mechanical engineer and like, oh, well, our industrial designer said it's going to be this little tiny puck. And then we need to have screws here, here, and here. And then you have to move all your chips around it. Ask me if I'm bitter. But like they're realistic, like, that pushing and pulling stuff around, especially at the beginning, usually you start to kind of firm up and finalize around there. Then you start to figure out what you can and can't do. So we're kind of open loop defining this sort of thing right now. So what I was wondering though is, do you guys have any pushback against switching to the S3, which is a very common ESP32 module as well? A little bit beefier, probably not ultimately necessary, adds BOM costs, which ripples through designs. Don't get me wrong, it ripples through designs, ripples through like other things you need. But the thing that I was thinking about is the fact that Dan was just talking about this, the dev platforms, and like all three of us have this one. This is the Core S3. This is an M5 stack, right? So like just starting from like a known thing there as well, not having to retarget later. You already have GPIO. We could remove GPIO expanders, that sort of thing. So any thoughts about that?
I mean, my only thought is that I'm right. What's the word we were using this morning? Evangelist. I'm literally by title a RISC-V evangelist. So
I think the S3 does have a RISC-V in it, but it's not.
It does. It's the ultra low power processor. but no, I don't have any problem with that. I mean, the S3 is amazing. It's pretty crazy what you can get at that cost, honestly. I'm totally fine with it. I also have, I think many of us have the C3 little dev board.
Right. Like a dev kit C style thing. Yeah, I have no doubt. And so like, but this is the kind of thing where I always talk about, like, at the beginning of a project, a choice you make now, and like this is true of hardware, it's true of IoT platforms, it's true of like architecture, RTOS, all these things. Like one choice can like really, it's like branching, it's like the multiverse of like, you know, really can have a lot of impacts. So like you know,
if you develop your ATMs on Windows 3.1, you might not have an outage like those who've chosen.
I was wondering if that was going to come up today. Yeah.
For those watching this later, there's a sort of issue, the global issue that
assuming that the internet works in a couple of weeks, John, who knows?
According to the reports, critical machines for airlines, banks, hotels, that are managed by a company called CrowdStrike, which is known for security and device management, pushed a bad update to these they're basically PCs, and they're all not working, and they're all running Windows, which was not great for Microsoft. But Dan shared a tweet this morning right afterward that apparently Southwest is still running because their computers are running Windows 3.1 circa 1996. So yeah.
I'm not sure that's actually accurate, but it was hilarious regardless.
But also sad that we're evaluating whether or not it's possible.
The Chris, so is the pin count really the main thing that is driving this for you?
That's driving this the current evaluation, really. That's the real thing. It is not you know, so like in terms of Sloshy McWashy, right? We don't have processing offload, things like that. Like other peripherals, to be honest, Sloshy McWashy is not that complex currently. One of the problems is if you had a product manager of, so like let's just pretend we're ABC Incorporated now. We're making Sloshy McWashy, and then the Rev 2 of the product, a product manager has like, okay, now we're going to do edge inferencing of this sort of thing. You need to have like a neural engine on board, right? Like the ripple impact of that sort of thing. So now it's like, okay, well, now we have to go and find a chipset that has a neural engine on it, right? This is like common silicon that's coming out. There's a new NXP part. There's some of the new Nordic parts are doing this sort of thing. Like this is a thing that's going to be in many things, but then to like hop vendors, right? So like imagine we're going from an ESP32, say S3, it's already beefy enough, right? But you need this one thing. It's like a defining feature at the hardware level. And then you're hopping to a new chipset, a new RTOS, like a new, like yada, 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 all the way up the chain, right? All the supporting hardware that's around it, that sort of thing. It might as well be like, you might as well just call it a new product at a certain point. It's like the family of products of that, Sloshy McWashy 2, Electric Boogaloo. Like,
you're not supposed to leak the second product.
The roadmap, the product roadmap.
We need to save the community center using Sloshy McWashy. Do you guys know all the tropes and memes from Electric Boogaloo?
No.
We'll watch them later. Send the links. And Chris, you kind of like building up like this cascading problem, like it's a one-off, maybe a one-off, potentially one-off thing, but actually we see this all the time, and I've seen this a lot too. They're like, oh, we want to switch to cellular. Like, let's just
no big deal.
Swap it.
No big deal. Yeah, we can just add cellular on, right? We'll have two ways of it communicating, like, right?
And it's a new product, like from the ground up, and oftentimes you might even have like engineers who learned one stack, one connectivity, like you're saying, one chipset, one RF style, and then a completely different thing.
Yeah. And so I think some of the things along the way do help, right? We should also state some of the things that do help in this way. So like using something like Zephyr or like ESP IDF, where you have like ecosystem level things where you're not, again, like bolting new stuff on, like that is helpful. And that could potentially, like, layers of abstraction in, I'm going to stick to Zephyr in this case, right? Like, you can have where you're operating and talking to different network layers, and like it's, just IP, right? Maybe that is somewhat similar there, but you're going to have to manage different firmware versions. If only you had OTA to manage different firmware versions and blueprints to do that sort of thing, like just shilling for Goliath as hard as I can here. So like things like Goliath and things like, ecosystems and RTOSs like Zephyr do help, but there be dragons. Don't confuse that. Like there is definitely stuff under the hood that you're going to worry about.
It's like the opposite of like, picking a vendor in a family and like sticking with it and say, hey, whatever we design from here on out has to like, fit within this maybe grouping, but like that's kind of setting our constraints. It's pretty common for sim chips to have chip families with like matching footprint, even if they're like different generations of cores, but like that's not something you can rely on.
Yeah. One of the things that like is coming to my mind while we're talking about this, well, first of all, like Slushy McWashy is obviously a one-off, or maybe a one-off, right? But I think like, the reason why we're doing this is like it kind of is a simulation of like building a product anyway. So I think it's good to have these conversations and to accept constraints which maybe aren't even there to like further that conversation. The thing that like comes to my mind is, in software, a lot of times there's this refrain of like premature optimization is the root of all evil. And, like that you can get too far skewed in either way on that for sure, right? And that's when folks get into trouble, right? You may be so unoptimized that it doesn't work at all, or you may spend all your time optimizing and then your company dies and it doesn't matter. But with hardware, I think one of the things that at least I'm kind of like gleaning from this conversation is the calculus is a lot different. There's I want to say a lot more factors maybe to make sure that, all our software engineers are happy in the audience as well. There's a lot different factors, right, that you're bringing into play here. And the like capital expenditure, right, can be huge if you get it wrong, basically. So I think it's interesting to like compare and contrast those two, especially, where Goliath sits and that we're kind of like bringing together software and hardware and firmware and all those sorts of things. So
I will, yeah, I think you're spot on. I think there are different parallel decisions that are really important, but the cost of changing them might be less than just pure software. So like, are we going to build a web app or an API? Like those are fundamentally different software products. But once you start building a web app versus building a backend API, maybe you do both, but like the thing you're building is kind of setting you on that path. And you have to say, okay, well, we actually are going to pivot to a mobile app now. Let's just like doing Sloshy McWashy 2.0.
Yeah.
Boogie.
And Chris also made a good point, I think, about like how the hardware impacts the software, right? Like if you're having to change the RTOS you're using, like that, think about how that impacts how you optimized your firmware, right? Maybe you did a lot of optimization building on ESP-IDF, and now you have to go to Zephyr, right? Something like that. Now, if you're using the Goliath firmware SDK, that would be a very easy transition. But but like there is a transition, so it's there is something fundamental about being like lower down the stack, because what we're talking about here a lot is like enabling things to be moved into software because it's more flexible there, right? So I think that's a good good tenet to have.
So should we try to answer Chris's question?
Yeah, yeah. That's about to bring us back. So I was just looking up the pins on both. So it looks like we have 45 on the S3 and 22 on the C3. Is that right?
Chris, seeing 38 on the S3, but maybe that's at a module level. I'm just following CNX software has a comparison side by side. I've seen 38 other places too, but
are we talking about chip up or are we talking about module?
Well, that's another question to be answered for sure. But I think it's actually going to be chipped down, which was another thing Dan and I talked about, because if you look at the available S3 modules, they only have certain form factors, and the Elixir has a ESP32C3 Mini, which is the smallest of the predefined modules on there because there's less external RAM and PSRAM and flash. So I think we'll probably go chip down. If we go S3, it'd have to be chipped down because there's just not room for the module.
If we're doing chip down, actually both. Espressif has a pretty good product selector. So you can see, oh, sure. Share screen.
Yeah, I think we should probably state the obvious here, which is, deciding on a stream is not really the best not the best time to do that sort of thing.
Why not, Chris? What if you're streaming every minute of your life?
Well, that's what we're doing for Sloshy here, aren't we?
Right. It may not be the best time.
Modern
but it's the time
influencers.
that we have.
Yeah.
I've been using Espresso Parts for a while, and they didn't have this. So like every time I see, I'm like, oh, this is actually nice, but it's actually on par with what most other chip companies have. But you can.
Will say that I keep ending up on this page now when I'm looking for other stuff. Though this is a very great tool, but when I'm looking for the docs, I somehow find myself.
Yeah. But so you pick SoC, and then you can pick the series. So we said C3 and S3, right?
Mm-hmm.
And they very clearly lay out which ones have which I/O.
Could you go a little bigger on your screen, John? Is that possible to zoom in?
Yeah, let's see. Like that?
Yeah, it's great. Thanks.
Nope, I can't make that any smaller. But yeah, it looks like S3 is 45 pins.
Oh.
Yeah,
and
on
then
the chip, but the module is less.
That was what I was looking at. Okay. Yep.
Oh, you wanted to do modules? Sorry, you want to do chips or modules?
Chips. Yeah. So I think the 6 pin difference I think is for the quad SPI that's going out to there's dedicated SPI that goes to the memory that's on the module and stuff like that. So that's something that we would follow along, of course, as well, right? Like that's
Chris, you're spot on. Look, this says 0 flash, and this says 8.
Yeah, exactly. Yep. But you would put it on so there is onboard SRAM. You see the next column over SRAM there. It's probably well, I guess we don't really use PSM RAM that much, but just knowing like the limits of where you're operating as well. Like that's another one where John kind of mentioned, like when you're in a family of parts, often you want to know I think STM32 has a super, super wide family range, right? That's a great example of like they will sell you a part that has, 16K of flash, and they will sell you the same core that has like 2 megs of flash, right? And there will be a huge price difference, but then you can actually optimize and start doing the cost down as you optimize your own code, and you get more mature of a code base and stuff like that. So that's like super useful. But it is important to note at this kind of stage of a process is like, what do I do if I'm screwed, right? What if my code is just too big? The code is too damn high. And having some way to top out or external flash or something like it, that is super, super useful in this context, I feel like.
So you kind of want to design your PCB so that if you need to add a revision with flash, you can. So basically you have to leave those pins free.
Oh, I think so. Yeah.
But
already it's way more than we would need. I think the real thing is like, you see the C3, it's the same regardless. They have dedicated pins that are not GPIO, right? So basically S3 dual purposes some of those GPIOs, I think, whereas C3 has dedicated pin. Like it's still if you go to it's a QFN32. So of those, some number of them are GPIO and some number are,
Yeah, because you can see this.
Yeah.
This one has flash, this one doesn't, and they still have the 22 available.
Yeah, exactly. Yeah. Oh, that is weird. I don't understand the difference between 11 and 12 on the index there.
Well, that's
because they're not modules, right?
Let's see if I can compare them.
Like that has to be off chip. End of life. Oh, there you go.
There you go.
Solved.
Yeah.
Oh, can you get rid of end of life in the filter?
That'd be good. The same thing. Yes.
Status. We only want actually SoCs that are end of life.
Well, if you want a discount,
I was actually
you really want to design on the edge.
For last week's stream, we were talking about accelerometers. I was looking up some common accelerometers that are in Maker products, and the MPU 6050 which I probably have 30 somewhere either between projects.
An XP part? Who makes that? ST maybe? I don't know. It doesn't matter.
No, it's
TDK.
Yeah,
TDK.
yeah. End of life, and they're still making and selling them like crazy.
Yep. Just don't get yourself into broker land. Whatever you have to do, stay away from the brokers, right?
Yeah, they're sharks sometimes, right?
They're the worst is the word I think you're looking for.
Is that
and if you're listening and you're a part broker, first off, you're probably not listening. I dislike your job. I don't like that you exist. Your job exists. You as a person, you're fine.
Is this like I've never dealt with a broker before. Is this like an SEO middle person? Is it similar vibe to that?
No, this is a warehouser and a
trench coat.
Yeah, that's actually not bad. Yeah. It's so they provide a service in that they have parts available that are hard to find. Unfortunately, they're also the ones usually who capture the supply and then mark the price up later. So it's an investment. Many of them have now retired because they made so much money during the part shortage, like gobs and gobs and gobs of money. Like just.
So you're saying we're pivoting, is what you're saying.
I have thought about it as a retirement thing. Retirement.
Yeah, I mean, I've definitely heard of brokers. I've seen them in the past. I know Chris worked in that industry or related to that industry when you're at Supply Frame with like.
Chris actually used to be a broker. It turns out
never was a broker. Don't slander me. That is. I'll send my lawyer after you.
Didn't Supply Frame?
Out, don't worry.
I mean, if you're have a product and you don't have parts, you have to go to a broker, right? It's like just the inevitability of that or redesigning your part.
Those are pretty much the two choices. I think there's a third choice, which is shut down your business. So and that's why brokers, they get you.
A lot of the supply comes
go back
from
to school, change your profession,
Yeah. And now I'm a
I've met a few more recent companies who are modern brokers who are more about like reduction of waste than to squeeze as much.
That's just being a broker with extra steps.
With a conscience, a broker with a conscience.
That's not with a conscience. Exactly. That's like, oh, we're a tech company now. Like, okay, are you still charging me $400 for a 20-cent micro? I don't like you.
All right, let's get back to our.
I would like to talk about this some more. I have thouts.
Yeah,
we're gonna have clearly scars.
Yeah, we are gonna have a dedicated episode. We're gonna have one of those, like this comedic format now, like a roast. Have you seen this? Yeah, maybe this is not new. Maybe I just sounded like I was 100 years old. But
yeah, you did.
You did. That was
all right. I'm sorry.
The Friars Club in like the 50s and 60s.
Let me tell you something. I didn't grow up with TV, so give me a break here.
Okay.
But we could just have a roast of brokers featuring Chris Gamble.
I don't know enough of them.
Research.
They don't have to
also, this is being recorded, and if I ever need to talk to one, I don't want it all to be on the record.
Yeah, well, it's too late for that. Anyway, back to S3 versus C3.
Yes.
Okay, and I filtered for mass production, so we should now see it down.
Okay, so we're only seeing that stuff. That's good. Yeah, I mean, so a lot of the stuff that we do internally at Goliath, we are not using the external flash and RAM. I don't think. I think most of the time we are. Maybe the flash we're using sometimes, especially for like firmware updates. So like, I think, so if I was going to put a chip down design, there would definitely be a footprint on board, right? I would so like my MO in this kind of case is like, go look at the S3, like the Espressive, breakout board. What do they call it? The DevKit C, DevKit M. They have a couple different formats. Copy the heck out of it, right?
But don't they usually use the module?
No, actually they're internal ones, like the black PCB ones from Espressive. Those are usually chipped down. If you see like the folded metal antenna, those are usually chipped down. I think lower cost. I don't think they have to get certified. So
makes sense.
Yeah. One thing to think about in this case, and we talked about this on Wednesday as well, is that like, I guess that one does have it. Oh, maybe I'm wrong.
I think the newer ones
are one right here, actually. I think. There we go. This is the.
Yeah, I guess I haven't seen any of them that have that, huh? Okay. Well, maybe they're getting more certification on these things then, or I don't know.
I also think they do such large volume that the cost is not important.
Yeah, right. You mean the higher cost of a module versus.
Yeah, so like it's easier for them just to source their modules. They're not selling that many dev kits, and it's easier than to spin up a board and
yeah.
Cool.
So I think one of the things to think about is like, so like thinking about Sloshy McWashy as well, we talked about accelerometer and similar things like that. Are there any other like kind of high level specs that we'd want to put in the future, right? So thinking about that, future features, you don't want to like overdo it, but like having some notion, excuse me, of like what you might need, ADCs, DMAs, things like it. That is useful at the beginning.
I think at one point you mentioned a potential Hall effect sensor, like,
okay,
in an alternative like concept. But I don't think we've come up with anything that requires anything that's not straightforward from the peripherals on a C3 or an S3. Even if we did audio, which I don't know how the audio would work in a water situation. Maybe
it's on the outside, right? So
yeah, I made a joke about throwing it into the washer, but it's not actually going to go in the washer.
Yeah. Oh yeah, that's right. Well, there are waterproof transistors you can get.
Oh,
okay. Waterproof. What?
If the joke idea where you're like throwing it in there, I'm like, oh, we can get a waterproof microphone.
Yeah.
Ignore that.
Going to be anyway. I think it would be in an enclosure, right? That would.
But the way the waterproof underwater transducers work, they actually touch the water. And
did you say transducers or transistors? Because those are different things. Oh, I thought you said transistor.
Oh, that makes even less sense.
Yeah. Okay. We're on more of the same page now, I think.
Okay. Yeah. So then for the externally mounted one, maybe either a magnetometer or like a sort of like a tilt like sensor, like again basic sensing to know which orientation is.
None of this stuff is like high needs, right? Yeah.
The high needs or high speed. If we did audio, for like just listening to the drum or things like that, again, like an I2S basic.
Yeah, you could do like high pass filtering even and just do like low frequency. Like all you need to do at that point is like the hum. You want to just get hum basically, which is harder to process. Like there's less data there. All right. Well, I'm going to go to DigiKey, which is my, so whenever I'm doing this sort of same exercise here, I will usually, even with those, even with the comparison things and they, show you the 1K pricing, like that's not quite as useful ultimately as like just kind of the gut check of like, all right, how much is a chip by itself, right? At like single piece price, I kind of have this in my head of like what it looks like. Screen to.
Also, we got a question here for, is it going to be battery powered? And yes, it will be.
Yeah. And I'm guessing that's coming towards the, S3 is higher overall current draw, but in sleepy modes, like, yeah. So single piece price, $2. Man, so cheap. I'll usually open a second window here. We'll just do side by side S3 and C3. I think C3 is like $1. So like, just adding C3, you always have to think about multiples as well. Yeah. So there you go, $1 in a single piece. So, it's not going to be double at volume, but it's a step up there for sure. And also support components as well, right? So like module size, things like it. So I think one of the benefits there though would be because we have a platform we know, the Core S3 is something we know and have been using, and maybe targeting a smaller part in the future also would be possible. But then to go back to the pin planning thing here, if you did a C3, you'd have to put some of these. So like anything in green here, or the Ys in this column, would have to go on an expander, right? So that's like a alternative thing you'd have to have there. So what do you guys think? What should we do?
Well, I will note that we can add it because we actually have most of it done for the AI pen project we did, but the the Core S3 is actually not the board isn't supported right now in Zephyr, but we could easily add that. So not a big deal. But just mentioning that as since we're planning on using Zephyr and have it.
Oh, the Core S3 development kit, not the S3 SoC.
Right. Yeah. But like I said, it's pretty trivial to add. In fact, we got it working as part of that project, so shouldn't be a problem. I mean, I'm feeling like the C3 is smaller and then has less pens and is cheaper. Is kind of like what we're looking at here.
And you need to maintain your ambassadorship status.
Right. Of course. That is the primary.
That's how they get you. That's how they get you.
Though you can keep it on technicality because the S3 does have a risk
right.
In it, so.
The ultra low power is risk, I promise. So the I think that if we want to like lean into the constraints, given that we don't have a lot of demands for peripherals here, the C3 seems like it's making sense given the constraints that we've talked about.
Okay.
But I'm open to. I would actually love some pushback on that.
Not sure I have any. I mean, the thing is, like, parts are so overspec. These, so like, this is the S3. Like looking even just at the C3 and what's on here, like, compared to like the first micros I ever used, like, it's just like so much more. Like, it's wildly available. You know. Yeah. I squared C, I squared S, 2 spies, GDMA. Controller, 2-wire. I don't know what this one is. Do you know what TWAI is?
2-wire interface. It's the non-Philips trademarked I2C.
There's an A in there, John.
I don't know what that is then. Forget it.
Oh, CAN. It's CAN.
Why?
CAN. It's CAN. I said it's a CAN controller.
I know, but I was saying like
a 2-wire automotive interface.
Oh, there you go. So they don't want to say CAN either. We don't want to say SPY. We don't want to say I2C. We don't say CAN, but we make up our own acronym. And
is CAN trademarked?
I don't think so. I don't know. Maybe this requires a certain transceiver to talk to CAN. Sort of thing.
Yeah. It says I'm looking at the ESP-IF docs. It's ISO. It's a specific ISO standard.
Yeah, this one here, 11898.
Mm-hmm.
Okay.
Anything CAN or CAN bus was trademarked.
Yeah. All right, let's do it. YOLO. C3 is our new constraint, and Dan gets to keep his ambassador. You get to go through that line at the international airports then, huh? As your ambassador.
Exactly. That's what they tell me.
Yeah, you should.
But
the walk up and you hold up your little paper badge and you got it like the.
But the card scanner is running Windows 3.1, just so you know.
Yeah. It's my it's got to be my a LinkedIn badge is what you hold up there. You know how you can like add those now.
Okay, cool. Well, then that doesn't change much on our side of things other than pin planning and and just to put a finer point on it, the DRAM is going to have basically 3 versions.
Oh, cool.
Right. That's the idea, is that you have the same castellated edges around the edge and the same effective functionality, but this will be version 3 that has an ESP32C3 as running the show, BG77 as an offload, a cellular offload, right? We talked about last time as an upgrade, right? But contrasting with what we said when we are just going to add cellular to it.
The Slashy McWashy Pro edition.
Slashy McWashy Pro, yeah. And then, have them optional. And then we could drop, if we wanted to, we could swap out in the future, target different things there too. So really making a lot of PCBs for myself here. That's a lot of PCBs.
What you like to do? Don't you just love to lay traces and drop PIAs? It's like your Zen mode.
Yeah. Traces everywhere. Did you see what Mike said in the chat here? The problems I've had with the Core S3 in Zephyr is getting the PMU working for some peripherals. Aha. Yes. Yeah.
Well, good thing We just selected the C3.
Well, that was specifically about using Zephyr though. So Mike's also been doing ESP-IDF stuff on the S3. So we are fluent in both.
But we are using Zephyr for Sloshy McWashy.
Yeah.
So what we've accomplished here is switching from the S3 to the C3. Did we say
Despite
we're
starting on the C3? Yeah.
Right.
We've
did we start on the C3? I mean, last week we decided on the S3. Yes, I have it. I have the notes.
We have notes. I feel like we've built conviction around the C3 regardless by having very informative discussions.
I mean, this is what happens. I mean, if we're talking about like ABC Incorporated, having discussions about a product, right? I mean, this is what you would be doing. You'd be in a conference room arguing this stuff, right? Or a Zoom call or
right. Success. So you mentioned though that we could use the module if we did C3. I didn't remember where we land on that. Are we going module or chip down?
I got to double check on that. I don't think we're going to use the module, but I think what you should probably consider in this case is that we're going to use the DRAM module, right? As a module is worth thinking about, right? And then how to think about this. So like, one thing I was going to mention that we probably don't have time for today, but we should do in future ones is like the next step is a different spreadsheet. And I would start basically getting rough BOM costs too, right? Because nothing like a gut check of like, oh, actually the BOM cost is going to be like $25, and even just applying a 4x multiple on that, like this, we could never ever charge $100 for this thing. Like, so that as a gut check is super important too, right?
Yeah, especially with the most expensive parts, transistors, caps, those kind of things are not going to move the needle. Connectors, enclosures would, but like, sensors and MCUs.
Yeah, things you never think about too. Boxes, stickers, like all the stuff that's on a full multi-level BOM. That like, oof.
If we're in trouble, we'll just do like sandwich bags.
There's some pop rocks in there.
Nice. Cool. Well, we are over an hour. Sounds like there might be some places people have to be. Is there anything y'all want to chat about before we wrap up here today?
Can we review the spec sheet that we've started building? Another thing that's good to do in this case, I think, is to build an actual like product spec sheet. And that's kind of what we started last time.
Yeah. So we have, let me pull it up here. So this is notes from last time, and then this is today. So over here, we had some options on the battery. I think Jonathan, you got an email about battery that we should be using, which is awesome. Please do send in suggestions via email or any other mechanism for us. And so, yeah, we chose Zephyr. Oh, no, this does say C3. Hey, Chris got us. He always knew. I even had the notes open, and you got me anyway. Anyway, so we confirmed our decision rather than switched our decision. Or I guess we switched twice. All right, so back to the C3, BG77. And then we had talked about this accelerometer. I want to say that we ended up in some discussion afterwards, which, apologies to the audience, we did not stream, was a different part in this family, maybe.
Yeah, the version 3, the LAS 3DH, I think.
Gotcha. Okay. So I can.
Also, I'd like to make my most nitpicky edit to your documents ever. Your date is wrong on the right side document. It's the 19th today.
It hasn't been committed yet, so.
Oh, good.
So don't worry.
Good peer review.
Title is right. Yeah. So I'll update that here. I'm trying to make the docs or the notes from the streams immutable, so that we have a record of making.
Yeah. So we don't have to scrub through the video to argue about stuff. You can just argue and say,
we can.
I mean, that's the thing. Like,
really...
I've been in meetings like 2 years later. We're like, why did we decide this? And like, having a recording actually would have been kind of useful, but having notes is, also very useful.
Good
and
notes.
The commit history. So if anyone tries to come in and change anything. So one other thing to note then, like as you said there, was the accelerometer. Oops. We said, would you say LIS 3DH?
I believe so.
Cool. Oops.
I would like to make a very important proposal. Can we do restructured text instead of Markdown for our notes?
I hope that my deep inhale there just came through over the stream.
It did.
It did.
I did side eye, but yours was more visual. I for the audience, I think Chris is trolling.
Yeah.
Mike's does not approve. And why was it that I can't remember. I can look back in Slack, but why did we choose the 3DH over? Was it availability?
I think availability.
Newer version.
Okay, cool.
Even like most of the like maker dev boards use the 3DH, not the one that we talked about.
Gotcha. And then was there other things that you wanted to, in addition to the notes? I think, Chris, you made a good point that like, since these are kind of like immutable, we should also have a like document in this repo that is like the locked in specs of whatever we're doing and decisions that are made.
Like a BOM document or something.
Oh, yeah. Well, BOM and product specs. So like so like imagine the data sheet you would make for Sloshy McWashy, right? That's always a good thing to start with, because then it's like, even to the point where you like start saying like, well, we were going to send to the cloud every 30 seconds or 30 minutes, or we'll respond within X number of seconds, like that sort of thing. Like having that written down, because that, again, like thinking about these rippling effects,
like batteries, for example.
Yeah, battery is a good one, right? Like we need a 2-year battery life, and it's going to be a 10 milliamp hour battery, right? It's like that's not going to work, like it just doesn't work. So, or if it does need to work, you need to do some insane, the BOM cost needs to go up because of that. Yeah. I think the nice thing is, once the data, if we figure out the data piece, get it onto the cloud, a lot of the stuff in past products I've worked on, a lot of the stuff that would need to happen on the device because of Goliath basically allows a lot of that kind of that modification and the other stuff that might happen, need to happen on the cloud. So
yeah. So I'm designing it for being extremely power efficient becomes the more of the focus, opposed to like algorithms and pre-processing and things like that.
Yeah. One last note for me is I've talked to software people, and not saying the two of you, but like just people from the software world building hardware before, which I'm guessing some people watching are also like in the same way. They're like, well, I'll put one thing on the device and then we'll test it out, and then if that doesn't work, then we'll iterate and try it again. So like in the example of like the accelerometer, my hardware people generally, I think maybe generally is bad. Me, like Chris Gamble, I am super paranoid, and I will throw as many things that will fit on there, right? So I will put a extra footprint down, but then you don't populate it, so the cost isn't there, right? So the footprints are free. That's up into the the extents of the board edge, and in this case where we don't have an actual like case, we have to be careful with that sort of thing. But like having alternative sensing capabilities when we're at this early stage is important, because you never know. We're still at the evaluation stage of like of a product. Is early prototype type stage. You need to like figure out the science piece first and still shuttle that data to the cloud, and then the next stage, EBT, PBT, like all that sort of stuff. So like engineering validation tests, production validation tests. And there's a DVT in there somewhere, right? Design validation tests.
Engineering, design, and production. And to that point, like on teams, I'm not a hardware designer. I'm not a hardware person. I've worked with hardware designers before they even get to the EVT phase. There's like, I've heard the term quals before, like qualification. It's like, does this sensor do what we need? And so as opposed to like, let's spin a board with this one sensor on it, they'll actually spin up, 10 qualifying boards to, to qualify, the parameters of a particular MCU or a particular sensor, and then build the sort of like EVT board from that.
So this could be an effective, EVT, right? This, if we were doing something like it, we could do something like that. But in this case, this would be Zephyr based on the 9160. So it would have to be reshuttled again later to the actual platform, right? So it also could be done with dev boards like Dan talked about, breakouts, flywires, that sort of thing.
Yeah. On the Elixir, so most of the stuff is wired up to the 9160, like the peripherals.
That's right.
And that sort of thing, right? Yeah.
There was an extra wiring that went to the ESP32. ESP32 is really just meant as a Wi-Fi offload.
Yeah.
So
cool. Yeah, that made me think one of the Oxide and Friends episodes, they've it was like a pretty long time ago. But they had a Power of Proto Boards episode that was really interesting. I mean, like they're obviously building like, a server rack, so it's a little bit different than Sloshy McWashy, but they kind of talked about their iterative process and like building these boards with lots of capabilities on them and making them modular so they could, swap in and out. And like I said, it's a much bigger system, so they're more thinking about like boards fitting together rather than we're thinking about like getting all of this on a single board so that we can test it out. But anyway.
Yeah, and you always have to be careful. Like everybody goes through a modularity phase, myself included. And I'm basically talking about it as well with like the DRAM module and things like it. Like modularity can be taken to an extreme, and you have to be careful you don't overdo it. Sometimes it's better to just glue it, like literally glue it together.
I think that's a parallel to what Dan was talking about earlier with premature optimization for software design.
Yes.
Modularity in softwares, but like that's probably the biggest mistake is pre-modularizing hardware from what you described.
Yeah. Sometimes it's better to just spend the time, expect you're going to burn the board, and then it's just a qual, like you mentioned, John. So
cool. Awesome. Well, I took the liberty of titling the stream "Footprints Are Free." So that's our official title for this week. But this was great. I enjoyed walking through this. I feel like this gave a pretty good view into like how you go about deciding, in this case, what MCU we're going to use, but what factors went into that. So yeah.
I know that was a really good wrap up, Dan, but I have one more thing. Just what did you have expectation wise for next time on the looking through like sourcing you said?
What do you mean? Like
you said, I think we'll do source, we're going to source some parts today. That's what you had said. So like, I figured you have some expectations of what that looks like.
Yeah. I think like, I don't know, going through and actually ordering things. Although in this case, I think we have we have a C3 dev kit. We'll need to get the accelerometer board. I think we found one on SparkFun or Adafruit or something like that.
That's right.
Yeah. So we could go through doing that. Because obviously like the PCB, when we're actually designing that'll be a separate process. But anyway, that's all I really had in mind. But we can also go through and figure out the BOM cost as well, which is not the same thing, but sort of related. So
yeah, to my kind of overspecking footprints are free kind of point, I would say we might want to, in the next episode, we might also want to dig through like Zephyr and look at like what microphones are supported, right? That's like a great starting point. It's just like, if it's supported in Zephyr as an evaluation kind of capability, very first and foremost, that's how I start most of the time these days. If I know I'm starting in Zephyr, what drivers are available, and then it's possible to work without drivers, but it's just so much faster to work with drivers. So
I also think looking at the Adafruit, SparkFun's priorities has helped us, at least in the past, because if they have a part for it and they have a lot of inventory, it probably means it's a easily acquirable part. And so like this Venn diagram of, does it exist in a lot of the maker distributors, product creators, and there's a Zephyr part that's like kind of a sweet spot for me, because I know that someone's already figured out all the pieces, how to buy it, and that their supply. Except for that,
and that's just to get to the data, right? It's not necessarily about the end spec that you need, right? We want like acceleration data, but we don't know if we need like to do like 100 samples a second. Probably some parts are going to be able to do that, some aren't. Again, we're working in a low constraint environment, so like we actually need to just kind of stick something on the top of a washing machine right now, as fast as possible.
And Sam was sharing that like a lot of these parts actually have even more advanced data, like fall detection and double tap, and like, do we need those? Are they useful? Do we end up have to writing our own? Like, that's where we start to need experimentation.
Cool. All right. Well, I've already done my wrap up, so we're just gonna get on out of here. But I hope you'll have a great weekend, and we'll see all of y'all next week.
Sounds great.
See you, folks.
See ya.